Okay, we're in section 14 of the notes and we're doing the examples. And section 14 is on determinants and the use of the determinant. All right, so let's just go through, simple. And it really, I would say that the basis of the determinant is really a 2 by 2. So if you know that, you can build on that to get determinants of bigger ones like 3 by 3 and 4 by 4. I will say this though, as time goes on and the sizes get bigger, it becomes really unmanageable to get them. But for a 2 by 2, it couldn't be easier. So let's write this one down. And I'm just looking at it, and it says determinant of this square matrix. Well, that's pretty simple. It's the multiplication of the diagonal, x times x. I'll write that down for you. Minus the multiplication of the other diagonal, which is minus 1 times 4. Oops, sorry about that. I made a mistake there. Minus 1 times 4. All right. So again, let me put on what I did. Multiplication of the diagonal here, x times x, minus the multiplication of this diagonal. All right. And what's that supposed to be equal to? The number 20. All right, what do you do now? Well, I got to solve for x. It's pretty simple. X squared. This would be plus 4 equals 20. Well, look, I'm back in 092. X squared would equal 16. I mean, there's a square root rule. And what's x? Plus or minus 4. All right, fairly simple. All right. Again, we're just trying to get familiar with how to compute a determinant at this point. All right, the use will come later. All right, let's do this one, number 2. And this is going to be what's known by expansion. All right, so I'm going to talk about what the expansion is, and I'm going to circle this for you. I'm going to do this one first. As I do that, these things are going to be crossed out. All right, so what are we going to get over here? We're going to get 1, right? Whoops, I didn't mean to do that. 1 times the determinant of that subsquare matrix. And what's that going to be? Well, the product of the diagonals, 2 times 2 is 4, minus the product of this diagonal, and that's going to be 3. Now, certainly, I'm not going to say you can't make mistakes doing this, but if you make a mistake, at least we'll know we've made a mistake by looking at the answer key. All right, let's keep going. I'm going to erase that now. All right, give me a second to do so. Okay, and now what I'm going to do, I'm going to do the next one. Now, what's the next one going to be? I'll do it in blue. So it's going to be plus and then minus. Now I'm going to do this over here and cross these things out. And I got another submatrix over there. As I do that, I want to claim to you what we're doing is we see a submatrix now, square, minus 3 times 2. And then it's going to be minus 3 times a minus 1. And I'll write that down for you. So minus 3 times 2 is going to be minus 6. And then it's going to be minus, well, 3 times minus 1 is minus 3. We'll do that arithmetic later. I'm going to erase that business over here. And we're going to do the last one. Last one, oh, I guess I'll do it in green. This one over here. And I write that down. It's going to be plus minus 1 times, well, let's talk about the submatrix over there. This is what's known as cofactor expansion. Well, I got the diagonals again. I'm getting better at this. That's 9 minus 6. Now let's do our arithmetic. We get 1. 4 minus 3 is 1. Minus 1 times, well, 6 minus a minus 3 is 6 minus 6 plus 3, which is going to be minus 3, plus minus 1, and 9 minus 6 is 3. So we give you 1. This will give you plus 3, minus 3, which is 1. All right, let's get our answer, see if we got the right answer. And lo and behold, we got the right answer. So what we do in problem number 1, problem number 2 is just, practicing how to get a determinant. And I'm not saying you can do it fluidly at this point, but you should be able to do a simple determinant for certainly a 2 by 2, and a 3 by 3 is not much of an extension over there. All right, let me erase the nonsense that's on the matrix though over here. All right, let me keep moving forward. And what we're going to do next, we're going to do problem number 3. Now, when I do number 3, someone's going to say, you're not following the instructions. Well, one thing I want to do is I want to go back to what I did in grade school for this. And, I'd probably draw a picture of the triangle. And I'm hoping it's a really simple one. And I'll do this over here. And again, if it's not a good picture, it's not going to be helpful. But I think I could probably get a stab at this over here. And I'm going to put the points down for you. And the first point I see is minus 2, 3. Okay, that point's done. What's the next point going to be? 2, 3. That's done. What's the next point going to be? 2 minus 6. Now, what they say? They say, well, I did the 3 points. They said that forms a triangle. Well, I'm going to draw the triangle in for you now. That looks like a pretty simple grade school triangle to me. Whoops, sorry about that. I'm going to shade it in because they want the area of that thing. And this is what we're talking about over here. I'm not doing a best picture. I know that. And there's a point to this too. I really don't think we should be doing this, other than the fact that it's simple. I can go back to basics. All right. So my question over here is that, what do they want the area of that? And I think I can do the area. How do I do area? I'll write that down for you. Area of a triangle is going to be 1/2 times the base times the height. Well, let's take a look at that. And one thing at a time. So area, 1/2. I'm going to go over here. I want to point out what the base is to me. I'm going to say this is the base of my triangle. And what's the dimension of that? Well, I'm looking at the units. It's 4 units long. I'm going to write that down. So the base is 4. And the next question is, what's the height of it? I'm going to say this is the height of my triangle. And what's the height? Well, just counting up the spaces over there. Again, it might seem like a lot of counting to you, but there's 9 spaces there, 9 units. Can I do that multiplication? Of course I can. What do you get? 18. Now 18 what? 18 square units. Okay. What do they want me to do though? They didn't want me to do that, but I do know the answer. They wanted me to use determinants. I'll write this down for you. So I want to point out what the determinant really gives me is that it's given me, and it has something to do with vectors, but let's not worry about that so much. It's given me the area of the parallelogram for this particular triangle up here. And that's if we pull this thing back to the origin, right? We could do that with vectors. But again, don't worry about that. I'm just saying that it's an area parallelogram, all right? So I'm going to just put down, the formula that we've given you, and I'll write it over here for you. Area is 1/2. It's plus or minus because these things can be rotated. When they're rotated, the area goes from positive to negative through a rotation, all right? Signed area. Determinant 1, 1, 1, and now I'm going to put the points down. Where the point's going to be? Minus 2, 3, 2, 3, 2 minus 6. And for me, I'll be honest with you, it's not easy, right? Determinants are not easy for me to do, but I think I'm getting better at it. I want to claim what I'm doing. I'm just doing this guy over here. I want to see if I can do that. And I'm going to write that down for you. It's 1 times something minus 1 times something plus 1 times something. Now I'm looking at the submatrices, by the way. Now I'm looking at the first one, which is, I'll point out the over here. So this is the submatrix over here. So it'll be minus 12 minus 6. Let me write that down for you. All right, let me do the next one. I'll point it out to you. We're doing this guy now. What's a submatrix? Well, it's going to be this column and that column. So it's going to be minus 2 times minus 6 is 12, and then minus 6. I'll write that down for you. All right, let's keep going. I'll put on what I'm doing. I'm doing this guy now. And this is the submatrix up here. What do you get? Minus 6, minus 6. I'll write that down for you. Well, what do you get here? And I'll write it down. I'm going to do the arithmetic now. That's going to be 1 times minus 18 minus, I'll put that in parentheses for you, 1 times 6 plus 1 times minus 12. And I make mistakes all the time. And I really want to fess up to it, but I know the answer. All right, minus 18 minus 6 minus 12. That would give you minus 36. So I know the determinant. So what do I get over here? I would get plus or minus 1/2. the determinant turns out to be minus 36. So what'd you get over there? Well, if you looked at it, you get plus or minus 18. Now remember what we said, this is a signed area, but we want the physical area. What's that going to be? 18 square units. So we use the determinant to do that. But you know what? The old-fashioned way, not bad, but they did ask you to do determinants. So over here, 18 square units. All right. That was number 3. Let's go to number 4 now. All right, number 4, I'm not drawing a picture. I'm just going to go for it. All right, so I know what area looks like. All right, they want an area. And let's write this down. I got determinant. 1, 1, 1. And then what do you get? Minus 4, 2, putting the points down, minus 3, 5, minus 2, y. And I want to compute this determinant. And I don't think it's too difficult to do. All right, we'll read the question later, but I know it has something to do with determinant. It's going to be 1 times something minus, with that in parentheses, 1 times something. And then what do you get? Plus 1 times something. And we'll go through it one step at a time. All right, we're doing this one first. There's a submatrix over here. What would it give me? Minus 3y minus a minus 10. I'll write that down for you. Minus a minus 10 is plus 10. Let's do the next one. I got this guy now. It's this submatrix, these columns. Minus 4y minus a minus 4. Now minus 4y minus a minus 4 is plus 4 then, right? Let's do the last guy. I'm looking at it. A little better at determinants. I'm looking at this submatrix now. Minus 20 minus a minus 6. I'll write that down for you. I'm just doing a determinant. This gives me minus 3y plus 10 plus 4y minus 4. And that would give you what? Minus 20 plus 6 is minus 14, right? And this gives me minus 3y plus 4y. That's just y, right? Right, just did these two here. And you get, let's see, minus 8. All right. I want the area. And what's the area going to be? Well, it's going to be plus or minus 1/2 times that determinant, which is y minus 8. All right. And what's the area? Well, I got to go back and read it. 13. All right, write this down, see if you can get it. I'm going to multiply both sides by plus or minus 2. And what would I get? Y minus 8 equals minus 26. Again, write that down for you. I'm multiplying both sides by plus or minus 2. All right. By the way, I'm going to be a little spiffy here. I'm going to write a little differently. I'm going to say minus plus 2. Get my eraser out and do this guy over here. I know it's crazy, right? And you're going to get, sorry, I made a mistake already. I got to write it down. So you get y minus 8 when I did that. And you'd also get y minus 8, equals minus 2 times 13, which is plus 2 times 13, which is 26. Well, I got to see if I can solve those equations. They look pretty simple. What do you get? Well, I'm going to add 8 to both sides. You get minus 18. Or let's see, if you add 8 to both sides, we get y equals 34. So I'm going to say the answer to this one is going to be this. Now, the determinant, you're going to make mistakes on them. You can go back and look at the answer key and see if you did okay. And you want to verify that. Minus 18 and 34. Working out really nicely. All right, let's go to the next question. And the next question says, use Cramer's rule to solve this equation. And I'll be honest with you, I just want to talk a little bit at Essex. I've talked to a lot of teachers at Essex for a number of years, by the way, and they seem to be of a universal opinion that Cramer's rule should be used at all times in upper level courses to solve linear systems. And I'm thinking to myself that's the last thing I would do if I were doing it by hand. And the reason that determinants are not easy to compute. What would I use? I would use probably simple elimination or maybe substitution. That's what I would do. I wouldn't use Kramer's rule, but I got to teach Kramer's rule, right? So let's just do this equation over here. I'll write this down for you. And I'll go through what I would do if I were doing this. And I kid you not, I don't think I'd go anywhere near Kramer's rule for this. Now, if I were programming a computer, though, I would definitely use Kramer's rule, because a computer, as far as I'm concerned, this is very mechanical to use Kramer's rule. Let's realize what a computer would do to solve this problem. What I'm going to use what's known as substitution to do this. And I'm going to take that second equation and solve for y. And what you get? Minus 3x minus 5 would equal y. And then I took the second equation and I solve for y. And then I would take that and I'd plug it into the first equation. And let me put that down for you. 2x plus 3, well, what's y? Minus 3x minus 5. And what does that equal? 6. Repeat this. Second equation, I solved it for y because it was easy. Then I took that and I plugged it in the first equation. What do you get over here? 2x minus 9x minus 15 equals 6, minus 7x. I'm going to add 15 to both sides. And what would you get over there? 21, right? And what do you get for x? Minus 3. And so it says, how would you get y? That's simple. I'll tell you why it's simple. You plug it in over here. So if x is minus 3, what would you get? 9 minus 5, which we know to be 4. So I got my ordered pair. What is it going to be? Minus 3, comma 4. I see that answer. By the way, I didn't do what they said, though. So I got to do what they said. What did they say? They said solve for x and y using Kramer's rule. I'll write this down for you. And I want to put down, it's really easy to write down. I needed the coefficient of the coefficient matrix. So I need the determinant of the coefficient matrix. And I'll write that down for you. What's the coefficient going to be? 2, 3, minus 3, and minus 1. And I'm going to say that's really easy to compute that. Again, if I were a machine, I would say this is the way to go. It's really removing any other thinking. It's a formula. 2 times minus 1 is minus 2. And then we get minus 3 times 3 is going to be minus 9. And what does that give me? Well, minus 2 plus 9 is 7, right? Then what I'm going to do is I'm going to write down the determinant dx. And what's that going to be? In the column of x is what I do is I put down the constants, which is 6, 5. And in the second column, it would be just in the column of y's, which would be 3 minus 1. And I compute this determinant. And what would that give me? Minus 6, minus 15, which is minus 21. And to get x, really simple, all I got to do is this dx over d. And what does that give you? Well, dx is minus 21, and the d is 7. And what does that give you? Minus 3. Are we getting the same result? Yes, we are. Let's do the y. How do I do that? I put down dy now. What's that going to be? The determinant. In the column of y's, though, what I put down is the constant 6, 5. And what goes in the x's? The coefficients, which 2 minus 3. What's that determinant? I'll write it down for you. 2 times 5 is 10. And then you get minus 3 times 6 is minus 18. And what does that give you? 28. Now, what's y equal to? dy over d. What's dy? 28. What's d? I'm looking for it. Oh, it's 7. What's this give you? 4. Are we getting the same thing? Of course we are. All right. Now, Kramer's rule is nice if you're a machine. It's really nice. All right. I actually think substitution is easier. Now, the next one, which would be problem number 6, wants me to use Kramer's rule. All right. Again, if I were doing the problem, I wouldn't use Kramer's rule. What I would do, I would probably put down an augmented matrix and try to get it to reduce row echelon form, or at least in a form where I could pull the solutions off quickly. All right. Let's use Kramer's rule. First goes down as d. D is going to be all over the place. 4, 2, 8, minus 2, 2, minus 5, 3, 5, minus 2. And I'm going to do that now. I'm getting better at determinants. 4 times something minus a minus 2 times something plus 3 times something. And let's go through it one step at a time. I'm doing the 4 first. So it's this submatrix here. What do you get? Minus 4 minus a minus 25. Let me write that down for you. Now, minus a minus 25 is plus 25. We'll do that later. I know it's tough. All right, let's do the next one. Doing this guy now. It's going to be this submatrix, 2, 8, 5 minus 2. Minus 4 minus 40. I'll write that down for you. I realize what someone's going to say. These numbers are too big for me. I need to calculate that. I hope you don't. I really hope you don't. Now, you might get tired saying I need a calculator. I get tired too. Let's do this guy. This is the submatrix now. What does it give you? Minus 10 minus 16. And let's write this down. What do you get? 4. And that will be 21. I'll do that arithmetic later. It's going to be plus 2. That's going to be minus 44. Again, I'll do that later. Plus 3. And that's going to be minus 26 now. Now, I make mistakes all the time, but I'm certainly going to look at my key to make sure I'm not making mistakes. And 4 times 21 is going to be 84, right? And that's going to be, well, what does that give me? 2 times minus 44, minus 88. And then what do you get over here? Minus 60, minus 78. Again, it might be slower than other people. I want to get the right number. 84 minus 88 is minus 4. Minus 78 is going to be minus 82. Now, before I proceed forward, I want to point out, you're trying to build a skill set and see if you can do it. All right. Now, by the way, I want to claim over here, looking at it, I do see the D all over the place. It's right over here. And I'm feeling pretty good about that. I got the D right. Now what I want to do is I want to do the DX. And I'll write that down for you. And yes, a lot of writing. Now, if I were doing the augmented matrix, I think I'd be done by now. But if I were a machine, this is very mechanical. Very mechanical. Write down DX for you. Now, what goes in a column of the X's would be the constants, which would be 6, 6, 52. And what goes in the Y's? The coefficient on the Y's. That's the second column. What goes in the Z's? 3, 5, minus 2. And I know it's annoying, but I want to go through it with you. 6 times something. I'll put that in parentheses. Minus 2 times something. Plus 3 times something. Oh, well, I got to do that work now, don't I? Let's take a look at what we got over here. Doing this one first. So get the submatrix. Minus 4 minus a minus 25. I'll write that down for you. And minus a minus 25 is plus 25. All right, let's keep going. We're doing this one now. So we got this submatrix. Minus 12. Oh boy, it's going to be more difficult, isn't it? I'll write it down now. It's so difficult to write it down. And it's going to be 5 times 52. That's going to be 260. That's not so bad. That's a big number, though, isn't it? Let's do the last guy. What do we have there? I see minus 30. It's tough, though. And then 104, minus 104. All right, let's take a look. 6 times 21 plus 2 times minus 272 plus 3 times, well, it's minus 134, right? And I got to do arithmetic. And I'll be honest with you, I really don't enjoy doing arithmetic. I'd much rather have a machine do it. And 6 times 21 is 126. We'll check later. Boy, it's going to be a tough one, isn't it? Minus 400, minus 540, minus 544. I'm just going to just do that again in my head. 400, 540, 544. I feel pretty good about that. Minus, oh boy, it's going to be a tough one. What do you go there? 300, 390, 402. Let me check that again. 300, 390, and 12. Yeah, 402. It's going to be a lot of work. 126 minus 946. I think I can do it. And what's that give me? 820, but it's minus. And that's dx. Let's go over here and see how we did. Wow, I got it right over here. And I know I'm looking at what the x is now, and it's really simple. Whoever wrote the problem was very kind to me. That minus 820 divided by minus 82 is simply 10, and that's what x is. I feel good about that. Let's do dy now. It's tough. I'm not saying it's going to be easy for you. I'm going to do it. Maybe I'll do it over here. Lose track of things, right? What's a column of x's? 4, 2, 8. The column of y's now is going to be those constants, which are 6, 6, 52. Okay. The column of z's is 3, 5, minus 2. Well, I'm ready to do it. You get 4, and I'm getting a little better. That's minus 12, minus 5 times 52, 252, 60. All right, I'll put this in parentheses. Minus 6 times something. And I'm going to do this minus 4 and minus 40. I'm getting a little better. I'm practicing. That's why I'm getting better. Plus 3. We'll check on my key though. I don't get too cocky. And that's going to be 2 times 50 is 104. And 8 times 6 is 48. All right, let's keep going. That's going to be 4 times minus 272. I'll do that later. Minus 6. Minus 44. I'll do that later. Plus 3. And 104 minus 48, 52, 56. All right, let's see if we can do it. And I might do it a little strange though. And somebody say, you do it really funny. You really shouldn't be looking at someone doing arithmetic. You should do the arithmetic. We can't disagree on it though. So we say minus 800, minus 280. You may wonder what I'm doing, just this over here. 4 times 200 is 800. 4 times 770 is 280. 4 times 2 is 8. That was easy. Next thing is going to be plus. Well, I think I can do that. 6 times 40 is 240. 240 plus 24 is 264. Let me repeat what I did there. I know negative times a negative is positive. 6 times 40 is 240. 6 times 4 is 24. 240 and 24 is 264. And I can do 3 times 56. That's 150 and 18, 168. I'm going to keep doing it. It's a lot of work. That's why I don't like it. I'll do this first. That's minus 1,088. Okay. 264 plus 168. I'll write that aside. Let's see, 8 and 4 is 12. Some people have to resort to grade school, arithmetic, what you did in grade school. That's 13. That's 432. All right. I know I got a negative number here. What do I get? And again, I'm going to get my eraser. I'm going to erase that baby arithmetic over there. It's a lot of work, though. I would much rather do reduced row echelon form. So let's see, you get 568 and 88. And again, you might say, it looks like really strange. I don't think I understand what you've done there. You shouldn't. What you should do is do the arithmetic minus 1,088 plus 432. And you should get the same number I'm getting. All right, go back over here. And I want to put, I just did dy. Oh, maybe I made a mistake. Well, I got the right number. All right. Now, by the way, I'm going to claim that one was really easy to divide through by, but a lot of students struggle with this, and I'll write this down for you. So you're really given minus 656 divided by minus 82. I would just simply say 656 over 82. I'm a little alarmed by that number. I'll tell you why. I wasn't expecting anything so difficult. It's got to be easy. And why is that? We just pretty much give you really simple problems. I would say, I think I'm going to do long division. Back what I did in grade school. Now, 82 doesn't go into 65, but it might go into 656. I'm going to say maybe about 8 times, because 8 times 8 is 60 something, right? 8 times 2 is 16. 8 times 8 is 64, 65. Lo and behold, it is exactly what they said it was. It's 8. I'm going to do the next one. And I want to point out what we're looking at. And I'm going to pull it on the side because it's like all over the place. And you should realize this is what I'm more of a fan of reduced row echelon form using augmented matrix. But you have other teachers at Essex say, oh no, Cramer's rule is the way to go. It's really mechanical. And if you're mechanical, you can do that. I don't think humans are mechanical though. I think machines are mechanical. A machine would like to use this method, but a human wouldn't. All right. But you should know it. If you're going to program something, I would say probably you should be using, and let me just push this up a little tiny bit. I'm going to do DZ now. Whoops, go back to black ink. And we'll check it. 4, 2, 8, minus 2, 2, minus 5. See if I copied them right. 4, 2, 8, minus 2, 2, minus 5. And what goes in the Z column now? The constants, 6, 6, 52. I got to do that determinant now. 4. I'm getting a little better. So 2 times 52 is 104. And minus 5 times 6 is going to be minus 30, but it's minus 30 plus 30. Plus minus 2, put this parenthesis again. And 2 times 52 is 104. Minus 48. And again, we'll do that later. Plus 6. And what do you get there? Minus 10, minus 16. I got some arithmetic to do. You get 4 times 134. And you get plus minus 2 times 104 minus 48. Oh, I'm sorry. I made a mistake. I just realized that. And I apologize for that. I have to go back and erase. And I just looked at the problem. When I mean look at the problem, I'm looking at the determinant. I know I copied wrong. And I'm going to get my eraser out. And I apologize for that. And again, if you make a mistake and don't realize you make a mistake, then I would say, you're going to find out if you just do the answer over there. So I got to change this a little tiny bit. Put my eraser out here. Erase that now. Oh, by the way, I could still make another mistake. So that's why I like answer keys. I'll look at it. And what's 104 minus 48? Geez, what was I going to give you? That's going to be 56. Then I get plus 6. And that's minus 26. I got a lot of arithmetic to do. So I'm going to write down 400 and 120 and 16. I just did this. That's called the distributive property of multiplication. What's the next one going to be? Well, 2 times 56, fairly simple. It's 112. And what do you get up there? Minus, that's 120 and 36, minus 156. All right, let's keep going. See if I got it right. Let's see, I add those numbers together. Kind of just looking at it, 400, 120 is 520. Just going to do these right over here. 520, 536. Don't be intimidated. And do these now. That's going to be 600, 648 minus 156. That looks like a lot of work, doesn't it? Let's write this down. 648 minus 156. By the way, you're going to make mistakes. And by making mistakes, you're going to start to learn your strengths and weaknesses. All right. So what you get there? 9, right? That's not so bad. And 4. So what does it give you? 492. Well, I'm going to see if that really is DZ. I'm saying it's 492, right? Look at that. We got that one right too. And you should really be surprised when you get things right. Because a lot of people, they're just really sloppy with arithmetic. Now, of course, I hope you know it's an arithmetic problem you have to do now. And I hope you know that 492 divided by minus 82. I'll write this on the side for you. Is really just minus 492 over 82. And kind of looking at it, if I did long division like I did in grade school, I would say probably, looking at it, 6 times 8 is 48. So I'm going to say about 6. What's 6 times 2? 12. 6 times 8 is 48, 49. Remainder 0. So what's the answer over here? Minus 6, as they said it was. All right. Now, again, if you're doing what I asked you to do in prior section, which was that augmented matrix reduced row echelon form, you would have been done long ago. What's the problem though? We're trying to teach this mechanical procedure called Cramer's rule. And Cramer's rule, provided you can, compute determinants, and determinants for the most part are really hard for humans to compute, but machines can compute them really rapidly because they're methodical. They really are methodical to compute. And it works on even larger and larger systems where that reduced row echelon form is not going to be working out for us. All right, we're done with that. And you need to practice. All right.